This aerial's quite unique. It's another aerial made by RFI. It's called a CD29148-174, and the reason why this aerial is quite unique is it will cover the entire band between 148 megs and 174 megs. And in the packet, of course, you get the usual instructions. The CD29 series antenna provides greater bandwidth coverage without sacrificing antenna performance. Their no-tune design eliminates the need to tune in the field, hence reducing installation costs and complexity, while improving overall coverage of the desired frequencies. The integrated matching circuit is housed in a rugged, impact-resistant base for maximum durability, with a tapered stainless steel, highly flexible whip. The CD19/29 is designed to interface with the standard PL259 MBC mobile mounts, facilitating existing installation upgrades. So RFI make a bunch of antennas in a variety of bands, from 70 to 77 megs, from 77 to 85 megs, from 118 to 136 megs. That's quite convenient, that covers the entire air band, and 138 to 166 megs, and 148 to 174 megs, and that's the antenna we're going to take a look at closely in a minute. Now on the bottom of this sheet there's a blow-by-blow description of how you terminate the MBC base, including a diagram of what the thing looks like and some stripping measurements. There's the MBC base. Before we go any further, what we're going to do is we're going to have a look at a couple of these antennas that have been damaged and have been recovered in the field, or recovered from the field. Here's a couple of broken ones. This one's had the upper portion smashed off, and of course there's obviously a whip antenna. There's a whip antenna that extends from there. Here's one where the whip antenna is still intact, but the base come out of the moulding at the bottom here. So what I've done is I've taken to this with a hacksaw and let's just peel this open and show everyone on camera. There you go, and up inside here is a circuit board. This pin here obviously interfaces up into the inside of this antenna, and that's the MBC base at that end, and the circuit board is secured with two fixing screws here, and it's soldered onto the board. And we have a strip line circuit board with 3 inductors and 2 capacitors on that face of the board, and a ground plane on the other face of the board. So it's obviously these components here that give the no-tune design and increase the bandwidth of the antenna. Now, very handy, of course, because of its no-tune design. You don't need to know the required tune length of because normally you'd be trimming this upper section of the antenna. Just about every other antenna uses that facility, but with this antenna, no. You can simply bolt it onto the bracket on the outside of your vehicle, and it will cover the entire band specified on the packet. In this case it's 148 to 174 megs. So this antenna in New Zealand will cover the EN band, which is approximately 150 megs, and it will go all the way up to the EEX band, which is now becoming quite popular with the forestry people, and it'll do it with one antenna, and there's no need to tune it in the field. A recommendation from me, however, is if you're installing one of these antennas out in the field, after you've completed the installation, double check your installation with your VSWR meter or your Anritsu site master, just to make sure that that the thing's working correctly, that we haven't got a failure in a crimping connector, or a failure up inside here with a soldering problem or anything of that nature. And we'll get that warmed up. Now what we'll do now, cut this packet open and have a look at the components from within the packet. So it comes with a little top hat. There's the major piece of the MBC base. There's a lock nut and a locking collar, and a sealing plug that fits into the bottom of this. Down the inside of here is the one place that you need to apply solder with this particular base, and we'll show you how to do that now. The first step, following our instructions, is to strip our coax cable to these dimensions, and if you're doing enough of these, set your stripping tool up so that you can speed this process right up. Now I always find that it's helpful to separate the woven nature of this braid, so I'll just pull that out and kind of tease it apart so that it lies flatter, and then fold that down over the exterior of the coax cable. What we're going to do now is we're going to trim this and strip the end, following the dimensions illustrated here. Pay particular care to ensure that you don't strip the center conductor a cable away. Yeah, whenever I've done these, I've found it always best to actually tin the multi-strand conductor in the center. What it tends to do is just glue all the separate strands together, and you'll see why in a minute. Nip that off. What's going to happen here is we're going to wind this base on. It's going to wind, it'll be twisted onto the end of the cable like that, and the cable will go all the way up the inside and will be presented like that. This here will lie eventually, when we've completed it, inside the little fork inside the center conductor in there. There we go. Okay, now the next step is to solder the center conductor inside of here. And what I find, if I screw this on like this, works nicely to keep the thing upright. And I can then present my soldering iron down in here. Apply sufficient heat to be able to do the job properly. Solder it in there. When it's done correctly, the solder down inside there will have a nice shiny and decidedly wet appearance to it. And that's all there is to it. What we're going to do now is we're going to fit the plug onto there. We will tighten that up with a spanner to make sure that's not going to come off. And then we're going to get some of our dual wall heat shrink, cut off about 25mm of it, and slide it up over the cable and heat shrink it on. When it's done correctly, you'll see the glue ooze out. It'll ooze out from either end. It'll ooze out from there and it'll ooze out from here, and that then completes this sealing that particular fitting up. Put these on here so that they're available in the field when it's being fitted. And don't forget the little plastic hat. Now when you're soldering, of course, it's quite important to apply enough heat to ensure that the solder actually wets the two contact surfaces that you're attempting to solder together. If your soldering iron isn't hot enough and you just dab at it, all you'll end up with is a little blob of solder on the top of the terminal, and potentially you have a future fault. It's fairly easy to get to, of course, if you do encounter something like that, by taking the little inspection cap off. This CD29 antenna is a ground independent antenna, which means you won't be mounting it through the roof of a vehicle. And when you look at the arrangement here, you'll understand why. There is no rubber seal here. If you attempt to mount this through the roof of a vehicle, you will struggle to seal it up. It's not designed for that at all. This antenna is designed to be mounted on a bracket. So because it's ground independent, it's likely to be mounted on a bull bar or a bonnet bracket or a mirror bracket. I've got an old bonnet bracket here just to demonstrate. So the fitting is presented through the bottom of the bracket like that, and this top hat screws on the top, and then the whole thing is tightened up. This component here simply screws down on the top like that, and that's perfectly adequate sealing wise for this style of antenna. Bearing in mind, of course, it's not going through the weatherproof skin of a vehicle. We're currently looking at a RFI aerial. It's a CD29 series, 138 to 166.